How are you out there? Third video of the day, net present value computations, and we have a lot of the last couple models to look at. So let's get right to the spreadsheets and start working on that, looking at the textbooks and looking at the problems and getting this finished off for the day. 500 lines of Excel today, so we did pretty good for the online group, and it's a review for the live classes. You guys will see it again also. And here we go. Valuing a new computer system. We stopped here last time. Okay, and funny enough, this company called Obsolete Technologies, I'm sure that's a play on that. It says the system costs $50,000, is expected to last 4 years, and should reduce the cost of managing inventories by $22,000 a year. Now, you know, you have to look again. You're looking at things as the Western world looks at it. Saving $22,000 a year is like making $22,000 a year, but you don't actually have it from an outside source. You're just not spending what you already had. So that's how the Americans in the West in New York City looks at these things. So that's really what that means. So opportunity cost is 10% of capital, 10%. Should it go ahead and pull off the deal? Yeah, record keeping municipalities and colleges and the Federal Reserve Bank system and the companies themselves. It's real important to document everything you do, and when you don't do that and there's something goes wrong, that's really a troubling thing. So certainly these kinds of things are very real. And I know certainly at St. Peter's we deal with a lot of enterprise issues and what's available and doing things online, all these kinds of things. 2,000 a year. Okay, we can say that the computer, right, increases, right, because there's less expense for 4 years. Can you calculate the present value is what we're going to do. So again, looking at this, we have a 10% cost of capital. So again, we could invest in something at Morgan Stanley or something for that amount of money or that return, and we're not doing it. And we're going to get 22,000 savings 4 times, or we don't have to pay a clerk, and those are there's somebody that we don't have to pay. That's about a beginning salary in IT and a nonprofit or something like that. And I'm sure a couple of years ago when this book was written, that was probably what some of the IT guys were making. Now, if you sit on the PATH train, you see 60,000 will get you to 100,000 faster than anybody. You'll see those kinds of things up there. And now we're going to go through. We're going to go through the process of, again, determining the present value, the time at time 0, all those kinds of things, and we're gonna look at this, and you're certainly seeing the answer down there. And I'm looking to see if we do IRR with this. I don't think. This is just getting the NPV. Probably should have done the IRR with this somewhere. This was something else. Okay, that was something else, folks. Give me a second. Let me see if we have this. Yeah, this was the point of intersection of the previous problem. Yeah, I don't see IRR here at all. But we could do a fast, computation sort of on the side here because we have a little bit of real estate here. Yeah, we could throw something together on that, very quickly. What is it, 4 years with this thing? Because we want the equation. We'll sort of jam the equation down at the bottom there. What are we doing with this? This is this copy. Yeah, this is an incremental cash flow. We're gonna return to that. I just noticed we didn't fill that in. We're gonna return to that in a little bit. So don't worry about that. That's a little bit more of an advanced topic, and we'll get to that sort of at the end of things, but I'm glad I saw that up there because it's not filled in. But we'll get to that, so don't be concerned about that. All right, let's sort of throw this in here. What are we doing here? We am actually just taking this out a bit. Okay, we're gonna do 50,000, and this is not revised. Now, this is something we have one NPV, and actually we can even start writing these things like this. I was thinking about that whole. Modeling the equation. We have the equation. The equation is NPV in terms of R. I haven't taught calculus in such a long time specifically. You forget some of those things sometimes. We already have the equation for this. I don't have to be so concerned about that. Here's 50,000 right there, and you're going to get 22,000 4 times. Now, we could write it like this. Or we could use that summation thing also. We can go sort of either way with this. And you're not selling back out or anything like that, and this needs to make that a 4. Yeah, that's it. There's your MPV. And like I said, we can jam something together sort of on the side very quickly, try to determine when it sort of changes on you a bit. Actually, we can even do that right now. Give yourself a little bit of space here. Where are you going to do it? Line it up with that. Always try to be symmetrical as best you can. It's never bad. And you don't need the bolds. You don't need these things. Control B, get rid of that, and get rid of the borders, border type thing. And yeah, I did this whole border thing, but it became a little changing the colors became a bit of a hassle. And you have to go back into this thing and whatever, left border or outside border, and then no border. Yeah. Okay. Well, we're going to get to that. Yeah, you're in there, and you have all the cash flow sitting here, and you have all your percentages here. So this is going to be, yeah, you could work it like this. You really could. There's this F4. Your rate is, let's see, 280. You're good with that. Now these are all of these rates. This one, comma, this one, comma, this one, comma, and the last one. Okay, that's your MPV. And actually, what you want to do, you want to go back. You want to lock all these guys. All those guys you want to get locked. Hold D. And the 38, let's see what that means, equals sum. That might be the nominal. Yeah, that's what we thought it was. That's just the nominal profit. That's the accounting profit. That's without time value of anything in there. Is the 38,000. That's not doing time value or anything like that. Control B and get rid of this thing. And okay. There we go. And just Control D. Yeah, so see, this one, you didn't get it yet. Up to 20%, you didn't get it. There we go. So you're somewhere 27 to 28, somewhere in there, right? Yeah, is where it changes, and that's that's the actual IRR, and it's at what rate is PV0. Just sort of jam that in up here. Border, and this is just simply IRR. Bold, center, make it text. Right? We're adding things as we go here. Yeah, and we'll set that equal to something in a little bit. All right, so we looked at that, and with this we could just go because we're in business for ourselves at this point, so we could just sort of do this again. So we're going to copy this thing. We'll skip a line. Give you a few formatted cells here, and you're say equals 27, which is right there, and this is no longer a percent. This is 1/10%. Up to 28, which is right there. So copy this whole thing, paste in there, and again, you see where the changes that you get between 27.2 and 27.1, 27.2. You're in there, and like I said, and you can refine this even a little bit more. You can say this is equal to that, which is right there, and this is 0.01. which is on there. 27.2, 0.1 and 0.2. Yeah, give us another 0. And you're in here. Increase this a shade. Like I said, you can go crazy. Which ones and all these other kinds of things. The 3.6 is pretty good, I think, for this. I don't think you're given the answer in the book, so we can't really check it. But I think this is good enough for that. About 27.128% on that. That's the IRR. Okay. You could move this thing over a bit. Do a little bit of a cut. Yeah. All right. You're in there. You can center the thing. Like I said, we didn't have that in our version, but we did a quick IRR computation. Now we want to find out what the present value of all the cash flows are. And when they're all the same like this, like I said, you can use that sort of shortcut version of this. Oops. Equal. Which is all that. What are we doing? Yeah, this is 10%. 10% plus 10%, and it's 4 years. Lock that. The green, the black. Yeah. I think that's that. $69,000 instead of 88 type of a thing. Yeah. Yeah. 69737. Okay. And like I said, and looking at this other one, we very quickly computed the net present value of this. This was example 8.1. Just to avoid getting things too confused, just throw the identifier on top of that. This is simply this plus 1,000, which is in there. So you're looking at 19. Your NPV is 19. So yeah, you're certainly blowing away what your opportunity cost, what you thought your opportunity cost was. You're certainly blowing that away by a lot. Type of a thing. This is going to be equal to the 50,000 plus NPV now, and the rate is 10%. And you want to get all your cash flows in here. This one, comma, this one, comma, this one, comma, this one. All that. All right, 19,737. We can value all of these at 0, right? Which is now today. Okay. All those. And this is 10%, 20, yeah, 20,000. Actually, we need to do to lock the rate. It's right there. And then you come down here. This is just a summation. No, surprise, surprise. The same number, 69,000. Now, 737 as opposed to 88,000, right? Which is, again, when you look at it nominally, that's what it looks like to you. But again, looking at it as the West looks at it, it looks at it in terms of an opportunity cost and that kind of thinking. And this other thing, this is just equal minus PV parenthesis. The rate is 10%. We have 4 years. We have all the same payment, and then 0 at the end. And surprise, surprise, about 3 different ways we determine the same piece every time out, which we're happy about. Okay, so there you go. I think that was all that this was. If you look in the textbook, I think this is all they asked. And now we're choosing between alternative projects. What mutual exclusive means, what independent means, mutual exclusive and capital budgeting, and the final problem of the day today is going to be choosing between these 2 proposals, proposal 1, proposal 2, and we'll look at that. And I think that's, yeah, that'll put an end to what we're doing today. Yeah, we're not going to hit. Yeah, this is the next section, so I don't have to worry about going to the right there. So, like I said, these things sort of go all over the place. I do a couple. I do an accounting one, do a finance one. So, I got a lot of these are bouncing around in my head often. So, mutual exclusive means it's a statistical term describing 2 or more events that cannot occur simultaneously. It's used to describe a situation where the occurrence of one event is not influenced or caused by another. It's impossible to roll a 5 and a 3 on a die, kind of thing. It's impossible without having an accident. It's impossible to take the same lane on the Parkway, the Turnpike, or the Tappan Zee Bridge, or the JFK Bridge, or not the RFK Bridge, or that other, I forget the big long one that goes to Queens, but it's not the Tappan Zee, it's something else. But it's the one it's the usually the RFK and the Triborough and all those bridges that go out to Queens. You can't have two cars going a lane, and now we have the overhead sensors, so there's no more real lane like in The Sopranos. When you look at the beginning of the Sopranos television show on HBO, they had the lane where the guy was taking the tickets. That dates when it was filmed. Obviously, it was way before, just before the Easy Pass. Easy Pass came out in 2000, and The Sopranos they started filming it in '99. I think they just kept the same beginning to that TV series, even if for the people who've watched, because it kept going until like '07. So for most of it, the time, Easy Pass existed, but they kept the same opening on the Turnpike. I guess for the Italians never like to change anything, so that's not a surprise that we saw that. So, but looking at this. You can't have a die that rolled two different numbers on the same die, or have two cars going the same, lane on the Parkway kind of a thing without having a collision. That's mutually exclusive type thing. Independent means one doesn't affect the next type of situation. So again, going back to the die example, you can roll a number, get a 5, and then get a bunch of other numbers right after that. And what you rolled just before you rolled the current roll, the dice doesn't have anything to do with the one you're rolling now. Stock market prices, S&P 500, all those are generally considered independent also, which means what happened yesterday doesn't affect what happens today. And let's look at some secure financial securities examples. The S&P can't close at two different prices, so it's mutually exclusive, and its price today and its price tomorrow are allegedly independent. So again, just another way to think. The die thing is the way that psychologists look at it, and different of the social scientists folks look at it that way. And then we have the capital budgeting is another version of this. If you only have 50,000 and you have two $40,000 projects and a $10,000 project, what you're spending on, how many subway stations that you're going to rehabilitate in New York City depends on your capital budget, and you can't do them all type thing if it's whatever. Let's say it costs, I don't know what it costs to rehabilitate those stations, but the whole price tag for the latest MTA project is about 20, 30, 40 billion, and there was another 20, 30, 40 billion dollar project that was already running, so it's in the tens of billions of dollars, and you divide that by a couple subway stations and a couple subway cars, and it takes, we're going to get them in 2022 or 2025, and we're getting them in these big distant, I don't know, it's not the space shuttle. I mean, I'm sure it's not simple, but it's not the space shuttle, it's a subway train. So I don't know why that takes so long to make these things, but I've seen stuff in the papers where we ordered some PATH train cars and they'll be here in 5 years, and those kinds of things with the Port Authority. And recently there was a lot of energy about how the Port Authority was running itself. Look, the bottom line is there's so many people working in the Metro New York area that the transportation system cannot get everyone to work at 9 o'clock all at the same time. That's what the problem is. And that's really what's going on. So I've heard of people getting almost practically pushed off the PATH train stations in Jersey City and those kinds of problems. But it's there's a lot of congestion on the public transportation, and certainly driving in is you have to leave at 5 in the morning or 6 in the morning to really reasonably drive in to Manhattan every day. That kind of a situation. So it's that's what it's facing. So like I said, but in terms of independence and mutually exclusive, always try to think of some everyday examples to make these very exotic statistical definitions and descriptors sound reasonable to you. So like I said, if you have in this example, you have 50,000, there's two $40,000 projects and a 10, you take the 10 and you take one of the 40s, and that's it. You add them up, that's your 50,000 type of thing. Okay, I think we spoke about this in class, and we're nearing the finish line today. I don't know, like I said, I don't know if this video is going to take an hour, but certainly we've been going a little bit so far. You have a couple different proposals. You have one project that's going to cost 80,000, another, I'm sorry, 800,000, another project that costs 700,000, and there's a certain amount of savings every year. And if you just nominally look at these, that'll lead you to your first decision as to what you should do, and then you a little more complicated analysis of the situation. So something costs 800,000, and it's going to last. Let's say both the expected useful life of 3 years. So I mean, you could just pick it up right here, right? I mean, that's what we're going to do. You're going to go here. It's going to be equals minus 800, 1, 2, 3, plus, you're increasing the cash flow for 3 years at 350, 1, 2, 3. Yeah. Okay, so you look at that. Nominally, that's 250,000, the benefit of that project. And this one is going to be, let's say, for 700,000, and you're increasing cash just by 300. So yeah, this one's like, yeah, the first one costs more, but it turns into better savings or increases in cash flow one way, either by savings or by actually bringing in a revenue. And the other one, it's same thought process, but it's cheaper, but it's also, you know, not changing cash flows as much. So that's your nominal analysis of this. Obviously, looking at this, you know, the net on this, you pick proposal 1, right, because it's a higher number. And again, you know, we get into this decision science, and to me, it's very obvious. But I stop, and people who are, I think, are good people and pay attention, all these things, and you ask them some of these questions, and they stop in their tracks and say, well, I don't know which one is better. And because I guess the detail is just somewhat overwhelming, but just looking at what's going on, one is they're both 3-year systems. One you can spend 800,000, the other one 700,000, and you have a cash flow benefit for 3 years. And with obviously looking at the first one, now this is not just cost, and you have to understand the computation you made. You came in at 800, and then you had a bunch of, you know, changes in cash flows. That whole, you want the higher of all this. The higher of all this is your net cash flow, just like an accountant would look at it almost. You know, so that's just 250,000 versus 200,000 for the second one. Okay, so obviously you want number 1 because it's a higher number. Okay, so look at what else we did here. We have cost of money or discount rate is 7%. Yeah, cost of capital 7%. All of them, both of them. Here's the other one, 7%, which is right there. Okay, you have both of those. Yeah, I'm looking on the right here. It looks like we have to also make a graph today of this. Yeah, it looks like we do. So let's just see what happens. And like I said, I want to be careful with this stuff because, yeah, all you have to do, because you already have the equation for this. So we want to be just aware and careful. Yeah, just align with some, because you have the equation. We were messing around with the polynomial thing before, and it caught my eye to try it. But actually, I in between videos, I looked online, and I have some material. We can create these polynomials. But after I thought about, you know, curve fitting to a polynomial equation, I said, well, wait a second, we have the equations. We derived the NPV equation to start out with, so this is just a part of it. Okay, so we have it. So go crazy, you know, figuring that out. You know, we want to do that. Yeah, this is the King Cole thing. That's for another lecture that we'll deal with that. Okay, you're here with this. Yeah. So we'll get to this thing in a little bit. Okay, we're here. So again, let's work the NPV for proposal 1, and determine the IRR, and then proposal 2, IRR. So yeah, so again, we're going to go through the steps of how to do all this, you know, another time today. And we're looking, so what do we have in terms of cash flows? Yeah, we have the first one. Hey, I apologize for this gapping. I'm not exactly sure what I was thinking with this gap, but okay, we'll just go with it. Is minus 800, 1, 2, 3. All right, we did all that. And we're going to get 350,000 a couple times. Okay, so we've got all those. And then you're going to do time value of money. And with this, so at T0, that 350 in a year, what is that worth? So that's equal to 350 divided by 1 plus the 7%, and it's a year. So we're using everything that we have here. Okay, 327,000 at 2, and slide over to this. OB, 1. Okay, so we have all those. 327, 205. So yeah, 350,000 in 3 years. That's what 285 today. type of a situation. I'm just going to add those up. I like this way the best, if you ask me. That gives you 918,000. Yeah, sort of the NJIT way of doing it is taking this thing times, well, like I said, we can go through, they're all the same, so we can use that sort of the shortcut summation method with this, right? And we're memorizing this formula as we go along, just from using it all the time. And again, we got to be careful with this. Apologize for that. So it moves on us a bit. And this is 3 years. And another process. Okay. Yeah, 19. And this equals negative PV parenthesis the rate, the number of years, the payments, and then your 0 at the end. Right. There you go. It's all that. Okay. So various versions of this. All right. Using the NPV function, rate, first cash flow, second cash flow, and third cash flow, and then plus 800. So you got your 118, and this is simply this plus what you came in with, the negative 800,000 to fund the project. So you can see that now you're comparing these. You're going to compare the rates. You're going to compare the NPV. So you're going to do all those kinds of comparisons with this. Okay, so you have that, and then we concluded at the bottom. Yeah, undertaking would include the value from now. Again, I never listen to any accounting commentary unless the guys wrote an accounting book. And when they say, "Oh, sure," but there's also you're also assuming a 7% return. So this is past that. Is really what this is. Okay, so you got to be very careful with these and this is sort of in the book, but you got to be very careful with the commentary from people who aren't accountants. There's a lot of value in the guy who actually knows the rules. Now let's look at the rates. We're going to start at 0%, type thing here. All right, we add by 1%, and now we're going to find the IRR. Is what we're going to do. And we went down to 20 with this thing. Control D. It's all the way down to 20. Alt HHN. All right. And let's see. Yeah, I mean, look, you could use to do the NPV. You could say equal, just to work the math a bit. Plus NPV rates, and then here's all your different values. F4, comma, F4, comma, 4, B, 9, and yeah. So this should help you. You're doing that. You don't have that division by 0 with the summation formula when you're working this. Control D, and actually, you don't need all these decimal places. You need 1. So you're right there between 14 and 15%, right? It goes from positive to negative. Okay, then it gives you your next starting point. Right, your next starting point will be 14%, and down here you're working on 1 divided by 10 percent, right? Is this, and you do all those. Control D, that goes up to 15, and now you can just take these, right? Because it's all formatted, all ready to go. Control, and once again, you're going to look for where you get the change. The change is 14.9 to 15%, right? Which is in there. Okay, so now you're going to go to 14.9 is your new starting point. And folks, yeah, these formulas, again, these are all the same formulas in here. This is just simply this. And you see what it's highlighting. You start your 800,000, your 350, you're rotating the rate now. You're not just using your assumed opportunity cost. You're saying, okay, let's test these to see where IRR is going to be, what IRR is going to be when NPV is 0. That's really what you're doing here. Okay, and you found. I'm saying you could say between 14 and 15, and then you can start cutting it down to more specific numbers, type of a situation. And this is this plus 1 over 100 percentage. Okay, and this is copy, and we're just going to do all the formulas in here, Alt HDF. Formulas. And we have all those, and then once again, we're going to pick this up, right? And then copy, because everything's formatted already, Alt HDF. And there you go. Once again, from doing this before, you're going to look at, it goes from negative to positive between 14.93 and 14.94, and you pick, even regardless of positive or negative, you pick the number that's, less of a deviation. So 57, even though it's positive, is less of a deviation than minus 75. So this equals that. Okay. So what is the rate of, what rate is NPV 0? 14.93. So again, you assumed again, I'm explaining what we're doing, not just all the details. You assumed a 7% cost of capital, and this project is really throwing off a 14.93% annual return. Okay, based on these cash flows, based on coming at 800,000, based on getting 350 every year. So again, you valued it at these numbers, and you underestimated your return. Now, if you picked just if it was 15 and that's what you picked as your opportunity cost, then this is NPV be 0, and you say, hey, that's it, that's the return. But now with this, again, just distinguishing between these, this is of the project, this is what you're giving up. So certainly, this project makes sense because the return is twice what you get at the S&P 500 or Morgan Stanley, fixed income fund or something like that. Okay, save your work as you go, type of thing. Keep doing that. All right, so we did all this, and now we're going to do the exact same thing, again, for proposal number 2. Okay, so again, just sort of clearing this out a bit, and it's going to be, minus 700,000, right, 300,000. Like I said, the great thing about having this on video is you can stop it and repeat it, and you can do all sorts of things like that with it. Okay, so this is going to be, and actually, let's see if I could just sort of maybe use some of this, reuse a bit, instead of just retyping everything. This is, yeah, so, well, it's the same percentage, so that's why it works, but it's a different one. So, okay, there it is. So, yeah, 280, yeah, that's all good. And equals sum, we're just going to add those up. And like I said, doing this, I never envisioned myself, making these videos and doing all this. So I think this is pretty neat, being able to, at your own pace and your own time, be able to work on this. Right, there's a lot of good stuff, with that. Equals negative PV, parenthesis, 7% for years, 300,000, and 0. Right, and there you got the same 787 again. So again, let's just check the present. Yeah. So obviously with this project, the present value of all these cash flows in 918 is higher than this. So that makes us lean towards, that may be better type of a thing. But as you look at this though, and yeah, and I just sort of cheating a bit. We're at 87,000 rand. Yeah. So obviously the first one is better, and the first one is better even from the accounting, just the accountant's version of this, just nominal. And I'll put a little comment in here. Nominal cash flows, right? Spell it the right way. That's nominal cash flow. Okay, how the accountant would look at it. Right. So that's that. Yeah, that's my only knock to the accountants is maybe they don't do as much time value of money. But certainly in terms of the rules, you want to listen to a CPA over any economist, any finance guy, because the CPAs know the rules, and it's all about those rules, the tax rules, and the assumptions that FASB makes, and all these other kinds of things. It's all that. So listen to those guys. Is my advice. Yeah. So this next piece here, I'm looking at how we did this here. Yeah, I did it sort of the. We could do it like this too. Equals parenthesis, just a piece at a time, right? 1 plus 7%, right? And this is this guy, and we'll just cover that in. Okay. Copy and paste. Paste, and now you got to go through. This is 100. This is 400. 1. Okay. So you have all that. NPV is simply this, what you come in with. plus present value, so it's 87,000. And we'll do it again, but just comparing. So here NPV is 118, here it's 8. Now, what you could find, and not even here, I was gonna say, because I just looked at the answer. Here you had a 14%, 15% rate of return. Here's only 13. So there's no indicator. There's none of the tests makes proposal 2 better, outside of the fact that it's cheaper, but none of them makes it better. Okay, so that there's probably a lesson in all of that. Okay, so in here actually we'll do the last version of this. So this equals that's 700,000 plus NPV parenthesis. Here's your rate, comma, value 1, comma, value 2, comma, value 3. There it is. I'll just sort of leave it up there for a second. I know I do these rather quickly. We're trying to get through these and move on to we have many videos to make. Is this is my high time of the year, the second half of every semester, because I always have the online course and the summer courses are coming. So we always try to get these. And I always try to do something different. So I'm always working on this, and I don't just repeat myself. It's ridiculous to just constantly repeat yourself. So okay, so you have all that, and now we're going to go through all this. Okay. And again, you don't need for this type of problem, you don't need a lot of decimal places, at least up to that point. How do we do this? Yeah, we can use the function for this. All right, this thing is locked plus NPV. And again, why don't I keep sliding over like that? The parenthesis, the rate is the one that varies, and then all these other, so this locks all the values locked, or the cash flows locked. So F4, comma, okay, all these guys. Yep. Always checking, just make sure. Like I said, do a lot of things, and want to make sure that we're giving you guys the right answers and the right everything, and you're doing it how we should do it. And of course, again, as you're looking at all the potential rates, and again, I said the paradox of this, the NPV declines as the rate increases, but that's just the math of the equation. So you have to just be aware of the economic meaning and just the mathematical meaning. You want a high NPV is what you want, but so I think just instinctively we say, hey, as the rate increases, shouldn't this be a better investment? But what it means is you're giving up something else, that's got a bigger return. That impacts it. And just the math of the equation, and what the equation is not a scenario equation. It's an equation where just one point, it has a lot of economic meaning, where the point where NPV is 0, where y is 0, where the y coordinate is 0. That's the only point that really has economic meaning, and that happens somewhere between 13% and 14%. Okay, and you can see, obviously, we're going to be closer to 14% because 13 is 8,000 NPV. This is -3.5, so obviously this is closer to the number that we're looking for, just sort of close to the 0, right? Because you're looking, that's what you're trying to find. At what rate is NPV 0? It should say it down there. Okay. Now your next starting point is going to be 13, which is right there, and you're going to equal this thing plus parentheses 1 divided by 10, right in there like that. I might just want to clear out all this, all page 10, leaving the now again. I'm sort of cheating a bit because I'm keeping the highlighting from before, so forgive me for doing that. This is just all HDF in there, and then copy all those. Okay, so we're in here, copy, paste, and you look at the whole piece of this, Control D, copy, paste. And this is just copy formula, right? Just the formula in there. And there you go. Okay. Yeah, it looks, for whatever reason, did I stop there for some reason? I don't know. Is that what I did? Yeah, I don't know why that's highlighted like that. 13.7. Oh, okay, I see what happened. We'll look at this in a second. But yes, so certainly in here between 13.7 and 13.8 is where your answer is. But it was so close to 13.7, we just kept that. I think that's what happened. Control D, which is in there. And there you go. And again, you're just going to grab these couple, which is right here, and Control D. So you're in here with your answer. So that's why we just sort of, right? 13.7 type of an answer. Close enough, because obviously the 13.8 is 1,000 away, and this is just 10. And even this 7.1 is 100 away, even though it's negative. So it says both cases are worth more than they cost, but the fair system would make greater contribution to value. So yeah, that's, and again, you got to be so careful. Like I said, I put my money on the accountant and the attorney, just from my years in private equity and seeing sort of who the important voice in the room is. It's generally the accountant and the attorney, believe it or not. The economist is listened to, but it's always looked at as very flowery. And like I said, sure, this is how far you are away in dollars, okay, from your NPV being 0. That's really what it is. And then what rate does that happen? And it gives you a rate type of a thing. So this is useful for determining really what the return is. But like I said, but you're comparing to your other opportunity is what you're doing. So obviously, and so now if this came out to like 6%, then but NPV was big, you have some kind of a trade-off. You'd have some kind of decision to make. Okay. So we did that. Yeah, that's the King Cole project, which we're not working on until later. But there's another graph we're going to make, and that's our last task of the day on this. And we've been doing a good 3 hours of videos today. And let's see how far we got with this. This was, yeah, went to 20, I think, with this. Right, went to 20. Okay. Yeah, for both of them. Went to 20 on both. So what you do is you'll highlight all this. You go insert, scatter. How do I do this? Yeah, I'll do like an interpolation. Okay, which is what we're doing here. And like I said, take a look at what this looks like now, and then look at the end, how good it's going to look, type of idea. Now this is the 13. Actually, this is the red one, I think. The other time we did it, we sort of did different colors. But yeah, let's make this all red and do all that. So chart layout. I picked the first one with the titles. Everything's got the titles. Legend, top, grid lines. Grid lines aren't bad, but I seem to be traditionally pulling them out, so just sort of kept doing that. You can always make it a little bit bigger, right? And I think we found, altering the axis here to move by a percentage instead of 5% seems to be in our best interests. 1 decimal place type of a thing. And also, I think we altered the alignment here. Like that, rotated 270. Okay. And like I said, you can always mess with the font. Have that font be a little bit smaller. 9 may not be bad, just to get rid of the you don't want those popping out. There's no reason for those to pop out like that. And this is discount percentage. Plot area, watercolor, solid, right, which is right there. A nice easy fill, a nice easy one like that. Yeah, like that, and below shadow. There you go. Okay, just all your pieces with that. Okay, and I think we have the title sort of in here somewhere. Internal rate of return, so I can just type that in instead of copying and pasting it, because sometimes the font, when you copy and paste, I bet the font gets out of control. And this can go to like a 14 or so or something like that. Okay. Actually, this is we're going to actually proposal number 2. So let's start changing colors. What was that? Okay. There you go. Nice and red. Okay. That's what that is. And you can move these by 25,000 if you want. Not 250, but 25. So a little more detail in that. And this is net present value, US dollars. So click in here. This is net present value USD. Okay. So yeah, but that looks like this is, yeah, and what all this stuff is. This is MPV profile proposal 2. So design. Like I said, you come to meetings, you got to be prepared and ready, and all these things with this stuff. It's really going to help you, with your, with your career and just communicating what's going on. Okay, so that's really what you're trying to do. So this is 13.7%. Folded everything. We're going to center everything the whole way around. I'm going to do your outline of this thing is going to be red. The fill is going to be white. And there you go. I think we just sort of found it a home under there somewhere. And you can mess with the font size and all that. Okay, and then we'll do the same thing for the other one. Okay, but there again, that's what. So again, think about what it looked like a few minutes ago, and what it looks like now. Okay, so you're making good graphs with all this. Right click, select data. You want to add your new X is proposal 1. Your new Y is also proposal 1. And just label, while you're here, just might as well label MPV file. Proposal number 1. Hit OK, hit OK. And there's another one. Okay, there you go. And again, obviously, let's do some fixing on this, make this thing blue. The marker changes markers dramatically here. Right there, right? Data series, option, built in. You don't want those bumpy ones. You got the 3. There you go. Okay. And it should look, yeah, this is 13, oops, 13.7. I put a comma. Easy to make mistakes with this stuff. Yeah, 13.7. Yeah. And this is about whatever this thing was. This was 14.93. So we can do, you can say copy, paste, and this is 14. I just copy and pasted it. This guy is going to be, the outline is going to be nice blue. And you're in there with that. There you go. I think we got it. So, yep. Okay. So there's your rate of returns, you make some nice graphs, and you're supporting your arguments. And we got through the first 450 lines of the model here. And obviously, by far and away, from a return perspective, from an NPV perspective, and even from an accounting perspective, the first proposal is superior to the second. That's really what we're trying to do here. So we're just going to take this, and like I said, as you get a sense of moving all this stuff around and all that. So we're just going to cover that. With that, like I said, you can make these things a little bigger. Okay. Save your work as you go. But like I said, so I know the course, the live guys, we've already seen this in class. Certainly try to go over this, and the online folks. I know it doesn't start for about 8 days, but getting a head start on this material is never bad. So you have about 3 videos. The online folks have about 3 videos to start with. We're going to get together next time for rate of return. Will be the next set of videos. Okay, and you have all the notes here. And like I said, the other tab here, we have the accounting cycle. We're going to have a lot of stuff with the accounting cycle that we're going to be dealing with. Okay, so you have all this stuff to look forward to. Hopefully, you'll learn a lot of things in here. And contact me, email me, and I want to talk to you. Okay, so this is the class. I'll put these classes. I put the videos up. I'm not going to put these classes up for a while. For the online section has the template, but I'm not going to just hand out answers. So work on this and a bit, and then we'll send it to you. And you can see I have the profitability index. We have that thing coming. We have mutual exclusive projects, and then we have a lot of the problems at sort of the end of the chapter. We're sort of a lot of these things that we're going to be dealing with. Okay, folks, like I said, please spend some time, read the chapter, uh, look at the Excel file, watch the videos, and get cracking on this, and we'll send out some assignments. Okay, work hard, read, study, and we'll see you soon.